What's up, party people? Day 2 of EOC review. We're going to write lines today. We're going to write lines. We have two forms for writing equations of lines. We have slope-intercept form. We have point-slope form. We call this slope-intercept form because M is the, you guessed it, slope, and B is the y-intercept. We call this point-slope form because, yes, once again, your slope is M, but I'm going to use another point. X1 is going to be my x value of my point, y1 is going to be the y value of my point. Looking at number 1, it says write the equation of the function given below in slope-intercept form. So I need to find the y-intercept. Y-intercept is also known as B. Okay, the y-intercept. Again, the y-intercept is where it crosses the y-axis, so it's going to be right here at 0, -3. Therefore, B is going to be -3. My slope is going to be rise over run, so I need to find another point on the graph. Again, a point has to cross in the intersection of the box, so another point would be right there. So in order to get from one point to one point, I went up 1 over 1, 2, 3, 4. So rise 1, run 4. So I have a slope of 1/4. Again, that's M. So all I'm doing is taking M, plugging it in place of M, taking B, plugging it in place of B. So y equals 1/4 x minus 3. Boom. There it is. Looking at number 2. Number 2 is the same thing. I need to find my y-intercept. Again, every y-intercept has an x value of 0 because, again, it has to be on the y-axis. So I cannot move over any. X value has to be 0. Well, I have the y-intercept right here at 0, 1. So B is equal to 1. Now, in order to find your slope, you're going to take y2 minus y1 over x2 minus x1. Change in y over change in x. So I'm just going to use these 2 points. y2 is going to be 1 minus y1, which is a -3, over x2, which is 0, minus x1, which is a -2. So again, minus and negative, you can change. 1 plus 3 is 4. Change, and make it 2. 4 divided by 2 is 2. That's M. So once again, we plug into our slope-intercept form. Y equals M x plus B. Number 4 would be done the same way. Again, number 4 here is your y-intercept, so B is equal to -2. So we know right now we have y equals something x minus 2. We need to find what M is equal to. Again, the way I find my slope, x1, y1, x2, y2. So we're plugging into the slope formula, y2 minus y1 over x2 minus x1. y2 is -2 minus 7 over 0 minus -4. -9 over -4. Sorry, +4, you dummy. So a negative over a positive is a -9/4. Number 4 and 5 ask me to solve for y. So I need to move this 3x. Again, the way I move something in math is to do the inverse. So I'm subtracting 3x. These are not like terms, so you cannot combine them. You've got -2y equals -3x plus 20. Last step, you divide by your coefficient, which is a -2. Y equals 3/2 x minus 10. We'll do the same thing over here, but at first I need to distribute my 1/2. Again, distribute means to multiply, so y minus 4 equals 1/2 x plus 4. Last step, you need to get the y by itself, so we're going to add 4. I'm going to add 4 here because those are like terms. Don't add 4 here because that has a variable that doesn't. Those are not like terms. These two are. So y equals 1/2 x plus 8. Alright, looking at linear transformations. Okay, looking at linear transformations. We're going to change the slope Okay, if you make the slope bigger, the line gets steeper. We call that a vertical stretch. If you make the slope smaller, okay, a fraction, 1/2, 1/4, a decimal, 0.5, then the line gets flatter. And we call that a vertical compression. Now, if you make the y-intercept bigger, if you change this y-intercept, the line moves up. If you make it smaller, the line moves down. So this controls the steepness. This controls up and down. So it says find g of x, where g of x is the translation 6 units down from y equals x. So we have y equals x. Y equals x is our parent function. It passes through 0, 0. We're going to move that 6 units down. So right now the y-intercept is at 0. We're going to go down 1, 2, 3, 4, 5, 6. The new y-intercept is going to be at -6. I didn't change the slope. All I did was change the y-intercept to a -6. I wrote g of x. You could write y equals x minus 6. It's the same thing. Now, when we say reflect across the y-axis, what we're doing is we're changing the slope to negative. Okay, we're going to change the slope to a negative. So right now we have a positive 1 for our slope. We have y equals 1x. Okay, we just don't write the 1 because it's understood. So it's a positive 1. When I reflect it across the y-axis, it's going to become negative. So h of x, which is what we're finding, the new function, is equal to negative x. I could write negative 1x if I wanted to. It's the same thing. It says the parent function's graph below. Draw the function that represents h of x, which is 2 times that function minus 1. So 2 times x, so this is h of x equals 2x minus 1. So we're graphing this function. Now, once again, I start with my y-intercept. My y-intercept is at -1. So I'm going to go, I'll just draw it on this graph. I'm going to go down 1. There's my y-intercept. All right, now from there, I'm going to use my slope. Slope is rise over run. So in this case, slope is 2 over 1. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. I can go down 2 and backwards 1. So this is your new line. Now, you see how that line is steeper? That line's steeper because my slope changed from a 1 to a 2. The slope gets bigger, the line is steeper. It's a vertical stretch. Number 4 says, given f of x equals x or y equals x, describe the transformations in this function. Negative 3/2 f of x plus 8. So we have 3 transformations that happen. We have this negative, that's the first one. We have the 3/2, which is equal to 1.5, that's the second one. And then we have the plus 8, that's the third one. All right, the first translation is a negative slope. Again, when I go back up here, I said that when I reflect across the y-axis, I changed the sign of the slope. So it was a positive and it changed to a negative. That means that we did what? We reflected across the y-axis. So that's what that negative right there is for. Now, the slope changed from a 1 to 1.5. So the slope got bigger. The slope gets bigger, it's a vertical stretch. So the second transformation, vertical stretch. And then lastly, right here, I have no y-intercept. The y-intercept's at 0. Okay, that's why there is nothing written after the x. But that changed to a positive 8. So if my y-intercept got bigger, which it did, it moved up. Well, how much did it move up? It moved up 8 units because it went from 0 to a positive 8. So I'm going to say moved up 8 units. You could also say translated up 8 units. Okay, those mean the same thing. All right, let's go on to some more examples. Okay, so we have horizontal lines, we have vertical lines, we have parallel and perpendicular. All right, horizontal lines always have a 0 slope, and it's going to be a y-intercept. Vertical lines have an undefined slope, and it's going to be an x. So again, horizontal lines have a 0 slope, and they cross through the y-axis, or they have a y-intercept. A horizontal line would look like this. A vertical line has an undefined slope, and it crosses through the x-axis, or it has an x-intercept. This would be in the form y equals 2. This would be in the form, this would be in the form x equals 2. This would be in the form y equals 3. All right, parallel lines. Parallel lines have the same slope. Same slope. I don't care about the y-intercept. All I care about is the slope, and they have to have the same slope. Perpendicular lines have opposite reciprocals. What that means is I'm going to change the sign. I'm going to flip the fraction. Alright, so here we go. Number 6 says write the equation in slope-intercept form with a slope of 1/2, and it contains the point 6, -1. Again, slope-intercept form is y minus y1 is equal to m x minus x1. So we have m. M is your slope. Slope of 1/2. Bada bing, bada boom. We have x1, 6, right there. We have y1, -1, right there. So let's write it. We've got y minus y1, which is the y value of your point. So y minus -1 equals m, slope 1/2, parentheses, x minus the x value of your point, 6. Now, once it's in slope-intercept form, this is not in slope-intercept form. We need to solve for y. So I've got y plus 1 equals 1/2 x minus 6. What we need to do is we need to distribute our 1/2. Y plus 1 equals 1/2 x minus 3. And then last step, move the plus 1. So we're going to subtract 1 on both sides. We get y equals 1/2 x minus 5. Number 7 says write the equation of a line that contains this point and is parallel to this line. Now, parallel lines have the same slope, right? So from this line, I get the slope -2. All right, so I know that my equation needs to have an m that's equal to -2. And we're going to use this point. That's x1, that's y1. Again, we're plugging into this formula right here. So I've got y minus y1, which is, again, the y value of your point, which we said is -5, equals m x minus x1. X minus the x value of your point, which is 2. So here I've got y minus -5. I can change and make that y plus 5 equals, again, I'm trying to get it in slope-intercept form, so I need to solve for y. So let's distribute. -2 times x is a -2x. -2 times -2 is a positive 4. And then last step, move the positive 5. We're going to combine it with the like term on the other side, so we get y equals -2x minus 1. Write the equation of a line that contains the point 9, 3. So again, this is x1, y1, and is perpendicular to the x-axis. Okay, if it's perpendicular to the x-axis, so that means that it's this horizontal line right here. Okay, but I want a line that is perpendicular to that. Okay, so I need a line that is a vertical line, meaning it has an undefined slope, meaning it's going to take this form, x equals. Okay, so I need to go back and look at my point. My point has an x value of 9, so x has to equal 9. Okay, number 9, same kind of deal. We're going to look for the perpendicular slope. So right here the slope is 1/4. So again, my perpendicular slope needs to have a different sign and a flipped fraction. So we're going to make two changes to this number right here. First of all, we're going to make it a negative. Next thing is we're going to make the reciprocal. So we're going to flip the 1/4 and make it 4/1. So my new slope of my line is -4. This is x1, this is y1. Same dealio. Let's plug it into our point slope form. Y minus y1, which is 2, equals m, which we just found as a slope of -4, x minus 0. Now, once again, we're going to distribute this slope. So I've got y minus 2 equals -4, x, 4 times 0 is 0, so don't write nothing. And then last step, move the -2. We're going to add 2 to both sides, and I get y equals -4, x plus 2. Write the equation of a line with a slope of -3, so m equals -3, and a y-intercept, b equals 4. This is easy breezy. Y equals mx plus b. We know what m is. We know what b is. So y equals -3x plus 5. Alright, look at systems of equations. So now we've got multiple lines. Woohoo! Alright, so here we go. What we're going to do is we're going to write an equation of both of these lines. Okay, both of these lines. Alright, looking at this first line, this is the tricky one. Right? That's a horizontal line. Okay, if I go back to my last page, I said horizontal lines take the form y equals the number, whatever number that is. Right? This is going through the y-axis at +2, if you can see we're going up by 2's. Okay, so this is y equals 2. So no matter what x value I pick, y is always 2. So y equals 2. Now the second thing, y equals, what I'm going to do is I'm going to start with my y-intercept. Your y-intercept here is at 6, so b equals 6. Now you look at your slope, you're going to go down 2 over 2. So 2 divided by 2 is equal to 1. So we have a slope of -1. So m equals -1. Again, we're plugging into this form. So boom, boom. So y equals -x plus 6. Alright, let's go to number 2. Do the same thing. I want to start with my y-intercept. Now we're going up by 1. So my y-intercept b is equal to 3. My slope, if we find another point on the graph, is right there. So we went down 1, 2, 3, 4, 5. We went over 1, 2, 3. So my slope, m, is -5/3. Now, once again, I'm going to plug both of these numbers into slope-intercept form. Right? So y equals m, -5/3, x plus 3. Now we're going to the next one. Okay, here's your y-intercept. Your y-intercept, b, is -3. So we know that's a -3. We know that it has a slope of up 1 over 1, 2, 3. So up 1 over 3. There you go. Number 3, last one. This has a b, or y-intercept, of +3. Its slope, here's another point on the graph, its slope is going down 1, 2, 3, 4 to the left 1. Okay, this is a positive slope, so we went up 1, 2, 3, 4, 1. So it has a slope of 4 over 1, we could just say 4, x minus 3. This equation has a y-intercept of -2, okay, and the slope is down 1 over 1. So we could say -1 as my slope.